Next, I'm going to talk about the setup of the M5x jammer. So how do you set up a jam scenario? It's very similar to how you would use a protocol analyzer, except for the actions. You're going to define a jam action in addition to the analyzer actions. So first of all, what you're going to do is look for some kind of event. It could be a configuration read, a TS1, it may be an NVMe event. When you see that event, you need to set up some type of action, whether it's trigger the analyzer or insert a jam condition. That could be delete a packet or modify a packet, for example. And then once everything's set up, you'll basically set up the analyzer and jammer to run either or run both analyzer and jammer together. As I mentioned before, the analyzer has different modes of operation. One is analyzer then jammer, or AJ mode. The second is AJA mode, which is analyzer then jammer then analyzer. So AJ mode supports up to by 16 and AJA mode supports up to a link width of by 8. These examples I'm going to show you are in AJ mode, but the same applies to both modes when you're setting it up. So just to demonstrate what the difference between AJ and AJA modes are, AJ mode basically means that the analysis part is before the jammer in each direction. So if I send a configuration read from the root complex, we're going to see it on the analyzer first before it goes through the jammer. And then when we see the acknowledge, we'll see the acknowledge coming back from the endpoint. And then we'll see the completion coming from the endpoint. And then we'll see the acknowledge coming from the root complex. So in each case, we see the packet before it goes through the jammer. AJA mode is slightly different in that it will show both sides. So we effectively have two traces, one with the before the jammer and one with after the jammer. So how do we set up the M5x? So we're going to have to select the mode of operation, whether it's AJ mode or AJA mode, on the top left side here. The platform is shown as the M5X. That will be automatically detected. We have to define if we want to do a snapshot trigger. That would be as soon as I push run or start recording, we would start recording immediately and not look for an event. In most cases when we're going to do jamming, we're probably going to switch to event trigger. The default layout here is for the simple mode trigger, and you can see that down below there's some trigger events which you can trigger on, and then some jammer actions. So the simple mode is going to be a more limited set of trigger events and jammer actions. Also in this setup window, we can define the clocking system. So we can define either internal to the jammer, or we can use external clocks coming from the system slot and provide that to the DUT. If we switch to advanced mode, then we're going to have many more options on how to set up the jam conditions. When we go to the recording rules tab, which will show up in advanced mode, when we click on new event, it's going to give us a new event that we can choose. So in this case, we've chosen a TLP, it's a transaction layer packet, in this case a configuration read. So you would drag that item across to the global state. This is also a state machine, so you could create a complex sequence of events which you're going to use for your jam condition. The global state will always apply, but then you can also have the sequencer which moves from one state to another based on the definitions set up in the trigger here. If we double click on that jammer or that event, then what we will see is the details on what we want to happen. So the action that happens. There's two tabs that are important here. The first one is the analyzer action. Do we want to trigger the analyzer? And the second one is the jammer action. So we'll cover the jammer action in a moment. In most cases, we probably want to trigger the analyzer. So we check the box here that says trigger analyzer. If we move to the jammer actions tab, the default setting will be for no action to be taken. Effectively, this means that the Summit M5X will behave like an analyzer. In this drop-down box, we can then select the different types of jammer action that we want to apply to the traffic. The first example here would be to delete a traffic element. So if we choose delete, we have to choose a number of times that we want to delete that. And then also we need to check the rules. This will give a different behavior on the jam. Another example would be that if we want to replace the packet, we could choose replace as the dropdown and then define which packet we want to replace it with. And maybe we want to replace it with an out of sequence TLP. Again, if we replace it, we want to make sure that we either check or don't check the rules checking for PCI Express. This will create different types of errors, whether these are selected or not. We can choose modify, and we'll show an example of this later, where we modify a packet. Again, it's very important to determine whether you want to check the rules or not. Just one note there on the count field. The count field by default is 0, which would mean that every time it would jam the item. We can change that to finite by just changing the number there. We can also insert errors. Now that could be a packet error, like we take the start token off the end of the beginning of the packet or the end of the packet, and then send that through. So when the packet comes in, we would process it and send it out. And based on the rules checking on the right side there, that would determine what happens on the other side of the jammer. We may want to insert a symbol error on a particular lane on the link. That will be done by choosing insert error under the jammer action and then choosing symbol error under the packet error type. Now you could use this with a sequencer to do it on a probability base. So you could say, I have a counter that counts to 100, and every 100th packet or every 1000th packet, you would insert the error. You can also insert packets or symbols. So in this case, you could insert a packet, insert logical idle symbols after the packet. This effectively would cause a delay on the link. So if you want to cause more latency, this could be a way to do that. You can also jam the sideband signals. You can jam PE reset, wake, clock request, and power break. So you may want to either assert or deassert those or just bypass them. By default, it will bypass those signals. A new mode that we've added recently to our analyzers is what we call script mode. So rather than doing it graphically using the sequencer, you can also create a script which will be used for the setup of the analyzer and jammer. You can actually create the sequence using the graphical mode and then switch to script mode, and it will allow you to edit the script and add other conditions. One key feature here is that you can add to the sequence a state to any state transition. So you can go from state 1 to 2 to 3 to 1 and so on. The controls for the jammer are shown on the toolbar at the bottom. You can start jamming and recording simultaneously, or start jamming or recording independently. If you start recording independently, it's just like using a regular protocol analyzer. There's also a small button for the jammer log, which we'll show later in the examples. This will show a list of the jams that actually happened during the trace. We'll also insert a packet into the trace which shows what the condition was met for the jam and what we actually did. So in this case, we can hide and show the jam packets. This one was actually a DLLP acknowledge, which was deleted. And this is one of the examples we'll show later. So this packet will be shown in the trace. So for example, if you're in AJ mode and you don't have the analyzer on the second side of the jammer, then you will still actually see what happened with the jammer by using the jammer packets. These will be inserted in the trace in the appropriate places. The traffic summary will show how many jams happened, and these are hyperlinked to the trace as well. And this is what the jammer log looks like. So you'll see a timestamp with the error condition that was actually added to the trace.